Hi, welcome to the Olympiad geometry. Let's continue our study on Circumcenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Here, I would like to show a problem from IMO. But before we start talking about this problem, I want to be very clear that I want to express 2 points in this video. The first one is that we should have the basic knowledge of some modern geometry, and I want to show how important it is. The second thing is that in some problem, it would be better if once you review the problem set, it would be better if you can think of how to draw it just with compass and rule. Okay, for the first thing I want to express is that we need the basic knowledge of modern geometry, especially in the Olympiad geometry. Sometimes students feel it's difficult just because they don't have the basic knowledge of the modern geometry. Here I show a theorem, and I show the source of this theorem. It comes from a book called Advanced Euclidean Geometry, which is written by Roger A. Johnson. I recently received an audience email that's saying he wants to learn some advanced geometry, but he feels that some problems from the videos are difficult. So he wants to learn from a textbook that as an intermediate level between his school textbook and my video. So I suggest to learn this book. It's called Advanced Euclidean Geometry. I think it's not that difficult if you can really work on it carefully. That's a book I would recommend for the first textbook for every student that you want to learn the Olympiad geometry. Okay, because it provides you enough the basic knowledge of Euclidean geometry. Okay, now let's look at the theorem. Theorem is saying that if two figures are similar with corresponding side parallel, they are homothetic. That is, there is a center of similitude O through which pass the connectors of all pairs of corresponding points. Let's just simply prove it. For example, I have a triangle ABC here, and let's just put another point D here. And we already know that we want to find a triangle DEF that has 3 sides are all parallel with triangle ABC corresponding, right? So let's just do the parallel line from D to AB. And we can arbitrarily find another point, let's call it E, right? And we already know that for the DF, it should be parallel with AC. For EF, it should be parallel with BC. So we can do parallel line from D to AC and from E to BC. We find the intersection point that should be F. So let's just define the DEF as a target triangle that we are looking at. So, what is the connection between the corresponding line, that is line AD, line CF, and line BE? As you can easily see from this figure that they all passing through this point. and this point is the center of similitude. And the triangle ABC and triangle DEF are homothetic. So let's just prove that all the corresponding point connections are passing through the center of similitude. So let's hide this line first, right? Okay, think about that. AD and CF, those are the corresponding points, right? The connection of AD and connection of CF intersects on a point G. So we know that triangle ABC is similar to triangle DEF. Of course, they are similar because AB is in parallel with DE, AC is in parallel with DF, BC is in parallel with EF. So all the three angles are corresponding to equal to each other. So that means AC, the ratio of AC to DF equals to the ratio of AB to DE equals to the ratio of BC to EF, right? And AC to DF equals to GC to GF, right? AC to DF equals to GC to GF. Now you can think of, we find another point that actually the intersection point of CF and BE, right? CF and BE. So BC to EF equals to HC to HF, and it equals to AC to DF, which equals to GC to GF. We proved this so many times that we already know if on a line that GC to GF equals to HC to HF, that means H and G are the same point, right? So here I put them all visible. Okay, that's the concept of homothetic and the center of similitude. Now let's look at the problem. See, this is a problem from IMO, so I wouldn't consider it as a very simple problem. It seems that three congruent circles have a common point O and lie inside of a given triangle. Each circle touches a pair of sides of the triangle. Prove that the incenter and the circumcenter of the triangle and the point O are collinear. So let's just draw the this figure. First we know that we want to find three congruent circles that have a common point O, right? So we can first define this common point. Let's define this as O here. So that's a common point, right? Because the three circles are congruent, so that means the radius are the same, right? Radius are the same means the radius we define here would be the distance from this common point O to the center of these three congruent circles. So let's just give some points here. right? So I give ABC. That would be our centers of 3 congruent circles. So now let's draw the circle. This is the first one, this is second one, this is third one. That is clear, right? Now we need to think about how to draw the triangle, right? Because these 3 circles, the circle A, B, C, are lying inside a given triangle. Okay, so now we think about how to draw the triangle. The triangle, each side of the triangle is tangent to 2 of the circles, which means we can just find, let's just do a polygon here, and just find the perpendicular line from each point to 2 sides. Right, now we get several points here. This point would be the tangent point, right? And this point would be the tangent point. Similarly, this point, and this point, this point. They are tangent points of the triangle we are looking for. So we can now define the triangle by connecting the tangents, right? So let's make the auxiliary lines are invisible, so okay, great. Now we have the triangle ABC, which has each point of ABC as the center of the circle, congruent circles, right? And we have the JKL, triangle JKL. Let me do this. Triangle JKL, that's a triangle these 3 congruent circles lies in, right? And we want to prove that the incenter of this triangle JKL and the circumcenter of this triangle JKL and the point O are collinear, right? 3 points are collinear. So how can we find the incenter of this triangle JKL? We need to find the angle bisector, but because we already know that KL and KJ are the tangent line of circle B, so we know that if we connect K and B, right, we'll find the line KB and line JA and line LC. Right, so here I want to make this to be more clear. Maybe here. Yep. Okay. So this point M here represent for the incenter of triangle JKL, right? And notice that when we draw the triangle JKL, we did the thing that from doing the perpendicular line, that DA is perpendicular with AB, right? DE is perpendicular with AB. And we already know that DA is perpendicular with JK. EB is perpendicular with JK, right? So we know that AB is in parallel with JK. Similarly, AC is in parallel with JL, and DB is in parallel with KL, right? Which means that angle BAM equals to angle KJA equals to angle LJA equals to angle CAM, which means M is not only the incenter of triangle JKL, but also the incenter of triangle ABC, right? Okay, now we think about how to find the circumcenter of triangle JKL. Right, we find the perpendicular bisector, and we know that this intersection point right, that's from the perpendicular bisector of this line KL and JL. So this point should be the circumcenter of the triangle JKL. And now we want to prove that MON are collinear. Notice that N is the circumcenter of triangle JKL, and O is actually the circumcenter of triangle ABC, right? And we already know that AB is for the two similar triangle ABC and triangle JKL, corresponding edges are in parallel, which means triangle ABC and triangle JKL are homothetic, which means there is a center of similitude. In this case, we already find it. It's point M, right? Because we connect the corresponding points in two figures, which is JA here and KB here. The intersection point is M. That is the center of the similitude. So we know that the corresponding point in two figures has a connection. The connection line of the corresponding points in two figures passing through this center of similitude, right? We know that. And because O is a circumcenter of triangle ABC and N is the circumcenter of triangle JKL, that means O and N are the corresponding points in triangle ABC and triangle JKL. So the line of the connection of point O and point N should passing through the center of similitude, which is M. Then we finish the proof that M, O, N are collinear. So you can see, if you know this concept, you know the concept of homothetic, this problem is extremely easy. It wouldn't take you longer than 10 minutes. But if you don't have this knowledge, I think it's a very, very difficult problem. Okay, that's 2 points I want to tell my audience. The first thing is that I want you to have the basic knowledge, which the book of Advanced Euclidean Geometry is a very good start. And the second, I want you to learn how to think the problem. When you solve the problem, you should start thinking how to draw the figure. And when I say draw the figure, I mean just use a ruler and a compass. Okay, I hope you like this video. See you in next one. Thank you.